Welcome to Session 9, Polynomial and Rational Expression Fluency. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to factor before simplifying, to cancel factors rather than terms, and to preserve domain restrictions. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Equivalent expressions can have different forms, but the same allowed outputs. Use this visual structure. Factor is greater than restrict, is greater than reciprocal, is greater than cancel, is greater than verify. Read every symbol and labeled before calculating. The first goal is to factor before simplifying, connected to the second goal. Cancel factors rather than terms. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Factor every polynomial completely. State the target and preserve its units or conditions. Step 2. List excluded values from original denominators. Use a separate line so signs, factors, and labels remain visible. Step 3. Rewrite division as reciprocal multiplication. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Cancel factors and test an allowed value. Verification is part of the solution because it tests the answer from another direction. Signal 1 is, 2 squares are subtracted. Respond by remembering. Use a difference of squares. Name the response before calculating. Signal 2 is, a rational product appears. In that case, factor before canceling. The form tells you which tool fits. Signal 3 is, a factor disappears. Remember, keep its original restriction. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Simplify x squared plus x minus 6 over x squared minus 4. Restate what is requested before touching the choices. The first move is, factor every polynomial completely. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Factor as x plus 3, x minus 2, slash x minus 2, x plus 2. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Rewrite division as reciprocal multiplication. The explanation supports one option without relying on its position. The mathematical conclusion is x plus 3 slash x plus 2. State it with any required units, interval notation, or restrictions. The final answer is x plus 3 slash x plus 2. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Evaluate original and simplified forms at one allowed input. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. If two algebraic forms are claimed equivalent, which check is strongest? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. Focused hint. Equal values at allowed test inputs can expose a simplification error. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is evaluate both at the same allowed value. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to factor before simplifying. Combine that with the discipline to cancel factors rather than terms. Finish by remembering to preserve domain restrictions. A result becomes dependable only when the method and verification are both clear. Reflection. Which excluded value would be lost if you recorded restrictions too late? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.